Hi, we're at North Carolina Agricultural Technical State University, and today we'll be talking to you guys about Quicksort.
I'm Lee Brown.
I'm Gerald Carlton.
And I'm Luis Brown,
I'm Jordan Dickerson.
And I'm Ronald Davenport.
and we will be giving you examples of following of Quicksort.
Hello, my name is Lee Brown, and I'll be explaining a couple things you need to know in order to do Quicksort. Quicksort is a sorting algorithm whose worst case running time is theta n squared on an input of numbers. Pivot is the number used to partition your array. And three things that you need to know in order to do Quicksort. 1, partition the array into 2 subarrays. 2, sort the 2 subarrays recursively. 3, combine all subarrays to complete your sorting algorithm.
Hello again, my name is Ronald Davenport,
And I'm Jordan Dickerson.
and we'll be showing you an example problem about how to implement Quicksort. So we have these array of random numbers, and we're going to pick a pivot point. We're going to use 16 as our pivot, and that means 12 will be our lower, and 49 is going to be our upper. So we use these points to compare to the pivot, and if it satisfies the conditions, then we can make the switch. 12 has to be greater than the pivot 16, and that condition isn't met. 49 has to be less than, so that condition isn't met either. So now we move inward. So now 1 has to be greater than 16, and 23 has to be less than 16. Those conditions aren't met, so now we move in. So now 56 has to be greater than 16. It satisfies the conditions. However, 19 is not less than the pivot, so we move inward. And now 8 must be less than the pivot. And since that condition is met, we can make the switch. And so now we have these conditions where on the left, we have all numbers smaller than 16, and on the right, we have all numbers larger than 16. So now we have our 2 subdivisions.
As Bernardo said, we have the array broken down into 2 subsets. This is the lower subset, this is the upper subset. 16 is already in order in the array, so we set it aside. We have now a lower, which is 12, and our upper, which is 8. 1 will be the pivot. 12 is greater than 1, however, 8 is not less than 1. So we move over. This becomes our new upper. 1 is less than or equal to 1, and 12 is still greater than 1, so we switch these. And now 1 has been sorted in the array. So we take this out, and 12 can become our new pivot and lower. And 12 is greater than 8, and 8 is less than 12. So we switch these to 2, and we have our lower in order. Now we move over to the upper side. Now we choose 56 as our new lower, 19 is our new pivot, and 49 is our new upper. So we start off, and 56 is greater than 19, however 49 is not less than 19. So we move over. 23 also is not less than 19, so we move over again, and we have 19 as our upper and pivot. And it meets the satisfaction, so we switch these. And now we take 19 out because it is already in the array now. It's in order. We choose 23 as a new pivot, 49 as our upper. 56 again is greater than 23, however 49 is not. So we move over to 23. That becomes our new upper and our pivot, and we switch these. And 23 again is now ordered in the array. So we choose now 56 as our new pivot. 56 is greater than or equal to 56, and 49 is less than 56. So we switch these 2 now, and we have our array in order.
Hello, my name is Gerald Carlton, and I'm going to go over the pseudocode for Quicksort. Here we have our array. We have int upper pointer, int lower pointer.
Next, we're going to randomly generate a pivot point within our array. Here, we're going to set the lower index and the upper index to the least and greatest indexes of the array. Next, we have a while loop that runs until LP is equal to UP. Within this while loop, we have two other while loops. This second while loop takes the lower corner indexes that are less than the pivot and skips them. Here, all upper corner indexes that are greater than the pivot are skipped. Next, we have LP. When LP is greater than or equal to the pivot, and UP is smaller than or equal to the pivot, the elements in each index are swapped. Then we have to call the quicksort method on each other parts recursively.
Alright, so now that we're going over quicksort, please tell me what this method here does.
Well, at the first line, it chooses a random index to be the pivot.
Okay, and what are we doing here?
At that moment, we're setting both the upper pointers to be at index 0 and lower pointer to be at the end of the array,
And why is that?
so that it actually sets up the bounds for when it quicksorts.
So what happens if this one here was +1?
It'll be out of bounds.
It'll be what type of out of bounds?
Index out of bounds here.
Okay. And why would we have these while loops here?
We set the while loop there so that it actually traverses through the whole loop.
And what are we doing here?
Right there, you're moving the pointers so that it doesn't continue to stay at the same location.
And what happens at the swap rate?
It actually switches the numbers at the beginning pointer and the upper pointer.
Okay. And most importantly, what we have to try to gather out of everything we've been learning in class, why do we have this method here?
It puts the number back in the array.
What? Okay, so we're initializing what here?
The pointer,
What is your pivot?
pivot's A.
Okay, so what are we initializing here? Alright, TA?
So this part of our pseudocode represents the actual recursion method within our quicksort method. This A, UP represents the actual array and that position in that array. This represents our original int UP, and this represents our int LP. And the reason these are switched is very simple, and I'm about to demonstrate. So, when we have our array here, this represents our LP, and this represents our UP. Now, if our pivot is 16, and since LP is greater than or equal to 16, and 1 is less than or equal to 16, we make the swap. So now, what this pseudocode is saying is that even though the numbers have swapped, this LP stays the same, and this UP stays the same. So now, even though those values have switched, the actual LP position and UP position remains the same. And that is where we get our LP position +1 to move over. And the value of this, since this position has been switched, is going to be our size minus LP minus 1.
Hello again, my name is Luis Brown, and I will be giving you a real-life example. Picture this, a global financial service bank with its investors as Cisco, Apple, Google, IBM, and Microsoft. Now let's say that all these companies trade at 1,000 shares. Now if we wanted to prioritize which company has sold the most for the week, the first thing we would do is choose our median as our pivot, which would then divide the array into a lower substring into an upper substring. Second thing we would do is choose a sub-pivot in our lower substring and in our upper substring. Now by choosing these two pivots, we will take these two pivots and recursively sort the array, which then will result in a sorted array.